Hi, I'm Tim Zacharias with Cougar USA and your host of Building Value. We're in Spring, Texas today at the Engineered Air Balance Houston facility and their training and lab facilities, and I'm joined by Vice President and Houston Branch Manager of EAB, Justin Garner. Welcome to the show, sir.
Hi, Tim. Thanks for having us here, and we're real delighted to have you here in our facility in our training center.
Awesome. Well, really excited about today's episode. We're going to be talking about total system balancing, system commissioning, and how they're using this training facility to better our industry. On Building Value, we go behind the scenes of building operations to showcase the people and products that make buildings work and the value they bring to the community. So can you tell me about where you grew up?
Sure. I'm from Louisiana originally, Baton Rouge area.
Nice.
Lived there until I went to school. Went to Louisiana Tech up in North Louisiana.
Okay.
I don't know how much you want me to go into detail there, but
what did you study?
So I studied industrial engineering at Louisiana Tech.
Okay.
So it's kind of funny. I never did any industrial engineering. I got a job here at EAB right out the gate, and a lot of folks said, "How'd that happen?" It's a funny story if we have time to tell it.
Yeah, go for it.
So Galen Richardson, who's former president of our company, he's about to retire, but he's still currently the vice president. He's obviously running this office the whole time I was coming up here. He went to recruit at Louisiana Tech because his wife went there, and she made him go. And he happened to interview me, and it's a funny story. He first interview question he asked me in the interview was, "Do you know the difference between a flathead and a Phillips head screwdriver?" And I laughed at him. I said, "You've got to be kidding me." And he proceeded to tell me, and I've since understood his wisdom. He was trying to determine my mechanical aptitude, right?
Sure.
Because obviously then we do a lot of field work here, so which was good.
Yep.
And then later on, I ended up interviewing for our San Antonio office.
Okay.
Because I really didn't want to be in Houston, which is kind of funny. And interviewed with our branch manager out there, but he at the time wanted a mechanical engineer, not an industrial engineer, so he hired someone else and called me and said, I gave the job to another guy, but call Galen, he might have a position for you. So I called Galen back, and Galen said, "Yeah, I made an offer to another guy, but I don't think he's going to take it, so if he doesn't take it by Friday, I'll call you." He did, and the rest is history, right?
There you go. I guess it worked out pretty well for everybody.
It did. It's, at first it was a little bit of a rocky start. I said, what did I get myself into? But then once I started to understand the industry and see what we do here, it's been a great career ever since.
So I guess kind of a two-part question then. What did you start out doing here? And kind of a follow-up to that would be just kind of generally talking about EAB and what y'all do.
Sure. So I hired on as a technician in training, a test and balance technician in training.
Okay.
At that time, we were not doing building commissioning or technical training as we are now. So our primary business was testing and balancing, as it's been since we were founded back in 1956. And so I came out the gate. They said, carry that ladder and pop those ceiling tiles, and then we'll teach you the rest as we go, right? And so that was a little rough at the beginning because you come out with an engineering degree going, why am I popping ceiling tiles and carrying a ladder? But then once you started to actually learn, once I started learning what we were doing, right, understanding how the systems operate, and why we were taking the measurements we do, because that's primarily, most folks don't realize, test and balance is a lot of simple measurements. It's you're measuring temperatures, you're measuring flows, you're measuring electrical data, amperage, voltage on motors, you're measuring rotational speed, and you have to put it all together. There's not a one instrument that you can put on the system and it measures everything, right? And so that's really what we try to teach our new technicians here is you've got to master how to take those measurements.
Right.
And then once you know how to take the measurements well, then you can start looking at what do those measurements mean and where do I need to take them to gather the data I need to see if the systems are operating the way they should be, or do we need to make adjustments, things like that. And so that's really what we're in the business to do from a test and balance standpoint. Everybody associates it with a flow hood and getting up there and cutting dampers. And that's part of it, but that's not the bulk of what we do, especially on today's systems in the heavier commercial market. That's still probably very true in light commercial because it's mostly constant volume systems. But you get into the VAV world, it's a lot more interfacing with controls, and looking at overall overall system settings and trying to get things where they need to be, both on the air and the water side.
Right.
And so it gets a little bit more complex.
And a lot of that you can't learn behind the desk, right? I mean, you have to be out and physically doing it to learn.
There is no substitute for experience in this industry, and we see that a lot. I saw that coming up in my career. You come out and you're told when you're in school for engineering, you're going to come out and you're going to be the boss. And I've had the opportunity to go back and talk to those professors and say, quit telling people that.
Yeah, that's not true.
Because that's not true. When you come out, you have the fundamentals, right? And so that's one neat thing about here at EAB is we have folks that have engineering backgrounds. We have folks that have other varying college degrees. We have a lot of folks that have other technical experience. They may have been sheet metal employees. They may have been service guys. It just depends. And everybody really starts at the same position here. They start as a technician in training, by and large, and unless they've got some significant air balance experience, which is fairly rare. And we have to teach them all those things.
Yep.
You have to teach them the fundamentals. You've got to teach them, what we teach in our training fundamentals class, which is instrumentation, identifying system components, and then how do you go about collecting all the data that you need so you can start that analysis, which then later on we're going to be teaching in our later classes is, what are the procedures to go about testing a airside VAV system. How do you test hydronics? So you just build on those fundamentals, and that's the way we've always taught everybody. But it became a challenge, and I think this holds true for the entire industry. You can't always show everyone everything out on a job site because you can't always control what's going to be there. We've always had a problem. Good example is a lot of our new guys, our new technicians. They may be 2 years in and they've only worked on air systems because working on hydronic systems, balancing hydronic systems, while we have them on every project, it's a very small percentage of our scope.
Gotcha.
And so that was one of the main things we wanted to do when we built this facility. You can see it behind us, our training stand here, is we wanted to be able to give some more in-depth training on hydronics and balancing and things like that. And we're really excited to start using this thing.
Yeah, and not only do you not have the option or the ability to see everything happening out in the real world, sometimes you don't want to see some of those things in the real world, right? I mean, there's things that you can generate in a lab situation like this, or kind of what we have set up over at the Local 68, where you can intentionally create an alarm situation that you wouldn't want to do in a hospital.
Sure.
Right? I mean, there's those things that you don't want to,
absolutely.
Unless you're kind of trial by fire, there's certain things that you don't want to learn out in the field, right?
Yeah, and or you may be limited, like you said, on what you can do, right? And or you may be limited to a certain technology or a certain manufacturer, based upon what's on the project at the time. And that's one thing, when we built this guy, we wanted to, open it up, and put, all the different technologies in there, everything like that. So we're really excited. We're hoping that's going to change the way that we can, both train our folks as well as outside folks. So.
Absolutely. So company started in the 50s, primarily been test and balance, but you've kind of moved into some additional areas, correct?
Correct. Yeah. So let me step back.
Okay.
We argue that since the 50s, when we were founded, that we have been doing what most folks consider HVAC commissioning.
Okay.
And that's really the functional testing part. If you're familiar with the building commissioning process, most people, they associate commissioning with come in and test the controls and things like that, functionally test the systems at the end of the project. There's a lot more to the commissioning process than that. But that's what most folks who are not in the building commissioning industry associate with commissioning. We've been doing that on HVAC systems since we were founded.
Gotcha.
The founders of our company, they put a big emphasis. Actually, the initial founder of our company, he worked for Tuttle and Bailey, and the whole reason he founded EAB was because he was going around the country. They were just coming out with the early VAV boxes. He was going around the country fixing the problems and essentially making the controls work.
Sure.
And he said, I can make a business doing this. And so thus he founded EAB. And so it really was founded not so much on airflow balancing. I mean, that was part of it, but it was more on the control side. And we've evolved that. And so we around 1999, 2000, we actually sat down and wrote control verification procedures. We had been doing it for since the 50s, but we sat down and wrote it and made it intentional and said we're going to follow these procedures. And so really that kicked off what would become our building commissioning group later on as well. And then commissioning became really mainstream and started being mandated by various codes and promoted by LEED and other things. And we really started seeing owners take off with it in the 2000s.
Okay.
I remember working on my first project, big job down in the Med Center, big research building down there. We'll leave the owner's name out of it, right? But big project, and we were working with a commissioning provider that was on the project, and we were doing the testing and balancing. And it was interesting. I don't want to pick on them, but we knew more about the controls and the HVAC systems than they did. They were running through doing their functional testing and telling us what to do, and we were constantly saying, it doesn't do that. It's not going to do what you want it to do because that's not the way the system functions. And it was at that point in my career that I said, I think we need to make a run at this one day. And Galen was already kind of working on that. And so around about 2008, we kind of convened some folks in our company that were really being involved with that in the industries where it would be prevalent. And we said, okay, if we're going to do commissioning here at EAB, how are we going to do it? And the big thing that we did is we looked at what other providers were giving our clients that our clients didn't like. We really looked at what was everyone else doing wrong. There's a right way to do it, but they were doing a lot of things that were not adding value to our clients, to the commissioning process. And we said, we're going to build our process differently. And that's what we did. We set out from that point on to build our commissioning program around value. It's around, let's let's follow the standard protocols, but let's give the client what they need. And the biggest thing we do there is, I won't say a lot more effort, but we focus our effort where it's going to give them the biggest bang for the buck. Sure. And a lot of times in the commissioning process, you would hear, especially back then, contractors complain about, hey, the commissioning agent just gave me this stack of checklists to fill out, and they told me to call them whenever I got it finished. And we said, okay, well, the owner's just going to get junk at that point, right? Because the contractor's going to fill it out as fast as possible. It may or may not be accurate, and that's may or may not be any fault of their own because they may not have the understanding, right, to fill out some of it. And and then the commissioning agent more than likely is just going to take that and stick it in their report. It may not even look at it. And so what value does that bring other than a stack of paper? And so we started with that process, and we said, okay, what part of this brings value? Number one, we want it to fit the systems. And so we built our program, our at least our online program that we use around that. Then from there, we said we want everything to fit the systems that we're testing. We're not using canned functional tests. We're not going to use canned checklist. Everything's going to be custom to the job. That way, when we give it to a client, it might be a stack of paper, but it all means something. Sure. It all matches what's there, right? Then the third part, and that's probably the most important, is we're going to be there. Even to this day, our commissioning group's gotten a lot bigger, and we've picked up a lot more clients. But our big selling point is that we are boots on the ground.
Sure.
We're not, and I don't want to pick on design engineers that do commissioning or anybody else like that. A lot of good folks out there. But our big thing is we're a field service company.
Yep.
Our folks are out in the field. They're going to be out there working with the contractors to get the right data, educating them, working with them to work through solutions, and then we're out there actually testing we're telling the contractors still manipulating the system to get through the functional test, but we're out there actually recording it. We're not just giving them the test saying, fill it out, and if you have a problem, call us, right? Which is what we were seeing. What we were seeing a lot of our competitors do, which is unfortunate. And so from that, we've been extremely successful. And all we were doing is what we've always done, but we expanded it from HVAC systems. Around 2011, we had dedicated folks, so we said, okay, we're not going to use tab professionals to do this anymore. We're going to start our own commissioning group, and it was dedicated folks. At the time, I was heading up that group and had a couple of really good folks join our team, and we got that going, and it's taken off from there. And now, we've got electrical expertise, life safety expertise, plumbing expertise, and our commissioning group is probably our fastest growing entity within the company. It's just been incredible. All because I think we're just doing what what the industry wants.
Right.
I mean, what commissioning was intended to do.
Yeah.
And so it's, same thing as our success in test and balance. It's do your job, do it the right way,
Right.
do it with with quality and integrity and consistency. And you don't always have to be the cheapest person on the block. So.
Right. And like you said, it's about value more
absolutely.
so than cost there. And
Absolutely.
for the owner to take over a building that is performing as it was designed and making sure that those systems are functioning properly is massive value to them. And I can attest to the thoroughness on the jobs. We definitely have worked with y'all quite a bit. And, even recently been able to come over here. My dad testing some sensors and stuff. So I know you guys definitely go beyond a checklist to make sure everything's working. So
we try. And then the other thing, we try to be part of the solution, right? A lot of folks, everybody complains about the commissioning provider's issues log, right? But I like to tell folks the issues log just brings transparency. It's not there to throw anybody under the bus. It's not there to beat anybody up. It's there to say, hey, this is a problem, and we all need to fix it. We don't just throw it out there and say have fun with it. We say, here's the problem. How can we help solve it? And these are the folks that we think need to be involved to solve it. And based upon our experience, these are our opinions and our suggestions. Obviously, we don't direct work, and we're not the designer of record. Right. But we try to be part of that process, and I know you guys do too. It's been great working with you guys on the various systems.
So where does that put you all today in terms of the total offering of services and kind of what your role is today?
So it's interesting because we haven't talked about training yet, other than briefly mentioning it earlier. So we've always trained here at EAB. That's always been a big part of, we have a mantra here that if you're not growing, you're falling behind. And that's held true since we were founded. And so we always struggled, as we talked about earlier, getting that training out in the field.
Yep.
Because you can do classroom sessions very easily, but getting the hands-on aspect was very, very difficult because you can't control the environment. And so it was always a dream of Galen's to have more hands-on equipment and setups that we could train in our facility. Sure. And so, I guess it was 2017 timeframe. I had an idea one morning. Drinking my coffee or whatever, getting ready to come to the office. I said, we needed more space here. And so I was looking at options to expand the office at that point. I was branch manager and running our Houston operations. I said, I need more space, and we've always wanted to, have this technical training ability. But it's going to be hard to justify that for just us. Sure. So how about we invest in what we really want? We offer it to the industry. We sell some of those training services because we've got the expertise to do that. It's going to benefit overall, and we'll recoup a little bit of our investment, right? We really built this place for us, but once we really started getting into it, we said, hey, this is a benefit to everybody. And since we've been doing it and really kicking off our classes, we were delayed by COVID last year. But since we really got things going the end of last year, first part of this year, we've had folks come in here that we never would have imagined. We've had owners' personnel join our classes that for test and balance professionals that we would have never imagined, right? And so it's been a great experience, and we're just going to continue building on that. And obviously, we have a great facility to use for our folks as well. Yep. So our folks go through the same classes. We really develop them around our people, and then we're just offering them to other folks. And we've had folks ask us, why are you training your competition? That's the first question I usually get, both from internally from our people as well as outside. They're, well, why are you training your competition? Doesn't that make you you lose your competitive advantage? And I say no. If we can give training to the industry, number one, EAB can't do. I mean, we have a large market here in Texas, and we are the oldest and largest independent balancing firm in North America, maybe the whole world, but we can't verify that, right? But we don't operate outside of Texas. Very rarely do we operate outside of Texas. We need good tab firms throughout the country. You talk to design professionals, you talk to other folks all over, owners all over, and have the opportunity to do that a lot with ASHRAE and things like that. Mm-hmm. There is a lack of technical knowledge, both from service technicians, it goes from the engineering side to the service side, install side, even to what we do in test and balance and building commissioning. Yep. And so it wouldn't matter even if we commanded the entire market here. there are other people that still need to be trained. There are other good folks out there that need this training. And so that's my answer. And if I train a competitor here in one of our markets, well, that's great. It just drives our services higher, right? We don't teach them the secret sauce of how we do things here at EAB.
Sure.
As far as our procedures, well, I say procedures. Technical procedures, yes, they're all the same. Some of our internal workings and some of the things that really drive why I think EAB is so good, it's all about our culture. And anybody can do it. It's just unfortunate there's a lot of folks out there that don't. And that's something I really didn't talk about earlier. But here at EAB, what we were founded on from the very beginning is what we call our core values today, which is integrity, quality, consistency, and teamwork. And, we've just always operated within those principles. It's never been about profit. It's always been about providing the highest value within the realm and exercising those core values to our clients. And I think if you did that, if everybody did that, well, the world would be a better place. But we won't go into politics today, right?
No, but I think it's incredible that y'all not only were founded on those principles and have probably been following along with some of those before they become mainstream with some of the latest books and everything saying got to follow your core values and stuff. So, but to take it a step further and actually live it, train people that may not be in your market, maybe your competition, I think says a lot about the company and kind of what your ultimate goals are. And so great to
appreciate that. Yeah. We're real excited about it. And everybody we've had come through our training program so far, we've had really good feedback.
Mm-hmm.
I mean, they say their brains hurt at the end of the week. It's fairly intense.
Yep.
But they've all gotten something out of it, despite, we've had some folks that came in here that really would probably be considered a little too experienced for some of our fundamentals class, but they still learned something.
Sure.
And so that means we built the class right, in my opinion.
Absolutely.
Even if someone with 5 or 6 or 10 years of experience were to come into the class and learn something, that's still valuable.
Yeah, I've seen the syllabus. It's pretty intense. I don't see how you could walk away with that without learning anything. So before we talk about the kind of the test stand and everything that you have behind us, can you explain I think y'all have coined that term, total system balancing. What does that really mean, and then how does that kind of relate to what we've got going on behind us?
Sure. No, that's a great question, Tim. So total system balancing was a term that was coined by, I believe it was by Walt Lipsky, the founder of our company. It was either Walt or Jim. And what it really meant was what we kind of talked about earlier. Testing and balancing is more than just, as we call it, rattling dampers. Okay, that's what everybody associates it with is proportioning air, proportioning water, but it's really about the controls. And going way back to Walt and really and even Jim Reed. I didn't talk too much about Jim, but Jim was just an incredible engineer. He had worked for Carrier, and then he was a design engineer, and then he joined Walt. And Walt was the salesman, and Jim was the engineer. Okay. And they were both great guys, and they both laid the foundation for where we are today. But Jim's big thing was it had to be almost perfect. I mean, Jim was very, very precise, and it had to be to the point where he would walk a building at the end of a job, and it had to feel right. Mm-hmm. You and I were joking about humidity earlier and things like that, but it all comes into the feeling of the job.
Sure.
And so that comes from controls.
Yep.
You can proportion air all day long. You can test the performance of a piece of equipment, but if it's not controlled correctly or applied correctly, it's not going to work.
Yep.
And and you can even go so far. I don't want to pick on designers, but even with all the technologies we have out there, there's a lot of technologies that are misapplied. Sure. And so even if the design's incorrect, you're not going to achieve the ultimate outcome, which is either comfort or safety, depending on the facility. We do a lot of work in healthcare labs, things like that, where safety is paramount to comfort. And then other places where it's it's comfort and energy that you're concerned about, right? And so you've ultimately got to understand what is that, and how do we. The only way to achieve that is the total package.
Sure.
And so that's how we really came about with total system balancing, because it's more than just proportioning and performance. It's, does the system work? Does it meet the design intent? You could even say that that's commissioning before building commissioning came along, because that's what building commissioning relates back to as well. And so Walt took that term, and we were one of the charter members of the Associated Air Balance Council, which is I don't know I'd have to go back and look at our timeline as to when they were founded, but it's on our history wall in there and in our training room. And so Walt got together with a couple other folks that were doing test and balance, Walter Cahoe, and I'm going to murder it. It was a couple other folks here in the U.S. informed that organization with the intent of certifying test and balance professionals. And when they did that, they had to write a standard, right? They had to write a standard for everybody to follow. And that standard was called the standard for total system balancing, because it focused not only on proportioning and performance, but controls as well. And it was, how do we make the whole building operate correctly?
Yeah, and controls is definitely where it is. I mean, that's one of the things that we talk about a lot with our systems.
Sure.
Is, I mean, you can select an efficient pump all day long for a specific duty point, but it doesn't necessarily mean it's going to operate there. And ultimately, it's the controls that are going to make the system operate and perform correctly, like you said, either for safety or for comfort. So,
sure.
Yeah, definitely have spent our focus on kind of that controls piece of the system, and then how it affects everything else going on in the building.
Yeah, I mean, especially with the codes now are mandating some they're good, but they are complex. Yes. Control scenarios and things like that, and it's good, but you have to have, number one, more complex control systems. You have to have, most importantly, the folks that can program them, and you have to have someone that commissions them, test them, be that the test and balance firm, or be that a commissioning provider, or maybe it's just the controls vendor. But someone has to make sure it functions,
right?
Because you can spend all the money in the world on it, and it won't work.
Yeah. That there's no value in that to the owner, right?
Correct.
So, what is this setup that you have behind us? It's very impressive training facility here, and I know we've contributed a little bit to some of the balancing valves here from Nexus. But what is this setup behind us, and how do y'all use this in the training classes?
Yeah. So let me move here. So what we set out to do with this scenario is we wanted to build something that would replicate a chilled or heating water system in an operating facility. And so you'll notice that we have 11 zones here going all the way across. And each particular zone, obviously we have different sizes. We have 1/2 inch, 3/4 inch, and 1 inch, just so we can get different flow rates. But the biggest thing we wanted to do was, you can see we've got individual flow measurement. That's the boxes up at the top. They're little inline ultrasonic meters. And they're there to tell us, as we're going and doing training, what our flow is on each zone. And then as you come down, we have, these are just manual balancing valves, but those are there to replicate a coil.
Right.
They're just there to set a pressure drop in the system. And then as we come down, we have, we wanted to put all 3 of the major technologies that are on the market in there. So we have at each station, and they're not necessarily always in order, but we have a manual balancing valve, we have an auto flow technology, and then we have a PIC, a pressure independent control technology. And then, obviously on the auto flow and the manual, we had to put a regular control valve. So everything's in parallel. So the nice thing is we can go through and train on everything, all the technologies that are out there, but moreover, we also tried to include every manufacturer that's, a major manufacturer that's in the market. We didn't get everyone, but we got most everybody.
Yep.
And we're very thankful to you guys for including Nexus in this.
Absolutely.
And so what was really cool is, you can go to a manufacturer's facility and they probably have this built out of their components.
Sure.
But we're not aware of anybody that has this, which is everybody in the marketplace, all the technologies built together, where you can really mix and match. And we can, what we really like to do, and what we're looking forward to doing in our hydronics class, is teaching them, how do you proportion with manual technology? How do you set up, because you don't necessarily proportion with autoflow or with a PIC, but it's not self-balancing. There are people out there that will tell you it is, but it's not. You have to still go and verify the setup on those devices. You got to make sure the right device was put in, the right orifice is there, or the PIC valve is set correctly, and things like that. And so we can go through and teach them how to do that. And then the cool part is, this takes years to normally learn in the field.
Right.
What happens when you put the system in control with each of those technologies? We typically do balancing at full design flow, but here we can actually put it in control, and most systems operate between 40 and 80%.
Right.
50% is a good number out there on any given day. what happens to that system when you actually put it in control? Well, we can see that here.
Yep.
And so to us, that's a game changer, not only for
absolutely.
test and balance and building professionals, but we're hoping to get design professionals in here as well. Because I've been sitting in ASHRAE meetings before and had folks with 20 years of design experience going, I can't teach my people and I can't get somebody to teach me how to design systems with PIC valves. And I know there are manufacturers out there that'll say, call me. Well, that's fine, but if you're a consulting engineer, you can appreciate the fact that you might want some objective, independent training, right? And so that's what we're hoping to offer here is come here and you can play with everybody's stuff.
Absolutely. And I think you hit on a couple of really interesting points there. I mean, the partial load operation most of the time is something that we've been talking about for a long time, and it's kind of funny. You think that the person that's selling the pumps wouldn't be arguing for smaller pumps, but a lot of times we are because we're through that whole process and we stick with it and stay and service the building after after commissioning and when it's in operation. So we know that if the pumps get in there, and it goes for any equipment, right, that if it's oversized, if it's sized for that max load that happens maybe 1% of the time, the rest of the year it's not going to operate that well.
Yeah, depending on how well it's designed, it's very difficult sometimes to get that turned down.
You don't get that turned down out of a single large piece, right? So we like a more modular approach to be able to get the turn down, but to be able to replicate that and show the impact on a setup like this is really interesting to see what happens at that partial load. And we had a, kind of like you said, we had a mini setup like this showing a couple of different technologies with just a little simple loop. And what was incredible is to see the change in one zone, the effect it can have on the others.
Sure.
And I imagine that with this setup, you can easily see that as well.
You can, and that's even something that's very difficult to see if you go out into a project, because you normally don't have flow measurement on every single coil.
Sure.
You can kind of tell, if you have experience, you can tell what's going on, and you can kind of watch other indicators and see what's happening. But folks that are not experienced, new to the trade, or people that don't go watch these systems through the control system all the time, they may not see that. And so we're really hoping this can kind of open everyone's eyes to, there's pros and cons to every one of these technologies. There's pros and cons to every manufacturer. Everybody's got their strengths and weaknesses, and so we're really hoping to kind of show that. And we're not here to beat anybody up. We want to be objective and just say, hey, I get asked all the time, what's the best valve here? What's the best here? And I say it really depends on the application.
Right.
There's some products that are out there that are great in one application and horrible in another, and you really have to understand those strengths and weaknesses. And I'm not going to pick on the sales guys, but a lot of times sales guys don't want to talk about the weaknesses, right? So,
well, and obviously from our perspective, the Nexus over here are the best flow balancing. But
sure, and I would expect you to take that position, right?
No, but I the same as y'all, we're in a lot of buildings, and it's not always exactly a perfect setup what you would want in that application. So being able to have all of them here to train your people, I could see the value for sure. Yeah,
we're really looking forward to it. We're in the process right now of finalizing the curriculum for that hydronics piece. That's going to be what we call our advanced technician series. It's going to have an airside component, a hydronics component, and a controls component.
Nice.
And so we're actively working on those, hoping to have at least two of those, the hydronics and the airside, out where we can start conducting that class hopefully by the end of this year.
Nice.
It's just you've probably built some training before, and until we started on this endeavor, we thought it was going to be pretty easy. But to build it to the quality that we want takes some time.
Absolutely.
And so we're still actively working on that, and but we're looking forward to it when it comes out. It's going to be neat.
Nice.
Yeah.
So the training setup here that you have, and we didn't really talk about it, but in the background there you have a whole electrical setup as well.
Sure.
But beyond the training facility, what other? You also have a lab set up here too, correct?
We do. You can't see it in the frame, but our testing lab is over here, and that's a fourth service that within certain realms we're very well known for it, but most people do not realize that we have the testing lab, and that testing lab's really meant to test airflow control components. Okay. We do a lot of terminal unit testing in there. What we really built the lab for, and what we're well known in the industry overall for, is testing laboratory control systems. So critical environment control systems. Our lab can replicate a basic, a basic science lab with a hood, a general exhaust, and a supply.
Okay.
Actually, our new lab here is much larger than our old facility, but we really gained notoriety in the industry back. Well, it goes way back to the 80s when Galen started doing it. We had a very rudimentary lab, and had I known you were going to answer that question, I would have brought the picture of our original lab because we got it in there in the control room. But we had a very rudimentary lab, and just to test dual duct boxes.
Okay.
And then from there, at our other facility before we moved here, Galen kind of built a small version of the hood, the general exhaust, and the supply back when the first laboratory control systems were coming on the scene. Because we have, if you're not aware, Houston is a huge market for basic science research. We have the largest medical center in the world here, a lot of research that happens here, so we have a lot of facilities that demand those types of products. And so that's how it started. And then when we moved to this address but didn't have this training center, we originally had our lab down in our other space where our offices are now. Mm-hmm. And we set out there to build a lab like no other. And we thought it was a really nice lab, and it was at the time. But that's where we really wrote the procedure that we're known for now. And so what we set out to do is we interviewed building owners that operated these types of lab facilities and design engineers that were designing them. And we said, if we were going to write a test protocol that tested everybody apples to apples across the different technologies that are out there, what would you want in the test?
Right.
And so we took their feedback and we wrote that test. And that test is kind of the gold standard in the industry now. It's almost, we've been referred to as the gatekeepers. I don't know that I like that because I don't want anybody feeling like they're entrapped to come here to EAB. But because it's gained such popularity among the design community, they've essentially said, if you haven't gone through EAB's test protocol, we don't want to consider your system because we don't have the performance data we need to evaluate what we were talking about earlier, which is how do I apply your product?
Right.
Everyone out there is going to say, well, my product's the best. That's fine. But our test protocol really pits every technology and every manufacturer against one another. And the neat thing about it is we haven't had a manufacturer that's passed every test yet. So that tells me that it's a good test, right? It's not, you don't have one product that dominates.
Can do everything, right?
You have one technology such as airflow control. If you know about lab controls, you typically have the mechanical style, which is the Venturi style valve. I'm not going to plug any manufacturer, but you have the Venturi style purely mechanical type device, or you have active airflow control. And our testing protocol tests both equally well. And one performs differently than the other. Typically your mechanical style valve is going to be faster, but maybe not as accurate, whereas the airflow control is obviously going to be slower, but it's more precise and more accurate. And our test really highlights that. And what we've gotten out of the design community, and it does a number of other things, testing the ability of the valve in non-standard conditions. I mean, we really put the valves through their paces, putting some really crazy inlet and outlet conditions on there and give the designers some really good information there to where when they're going to put one of these devices in a facility and they have less than perfect ductwork, they know how the valve's going to perform.
They know what's going to happen, sure.
Yeah, and so that's been a big value to them. And then we try to highlight some other items in there that are ancillary features, like what happens if you need to change your hood settings, what happens if you lose power in the facility, because that doesn't ever happen, right? But all these facilities typically will have emergency backup, but you're still going to have a short period of time there before the generators come on. We actually test that. And so what happens to the controls if they lose power, and then do they maintain containment, or what do they do? And that was a request from one of the designers when we built the protocol. So
interesting.
It's really neat that we've that was one of those things back when we first started. I had no idea it was going to grow to what it did.
Right.
But we really have become the testing standard in that industry, so to speak. And we forget about it sometimes because we don't do it every single day. But I've already had one manufacturer in here this year. We did have one last year. We got another one hopefully coming this summer. And so as the technologies emerge, as new players come in the field, as folks change their systems, we've even assisted some of the manufacturers to do R&D here because our facility is unique. So we're proud of it, but we don't always feature it probably as much as we should, right?
Yeah, that's really cool. I mean, and definitely one of those things that I would say flies under the radar in terms of what it takes to actually make those systems work properly.
Yeah, it's neat, and we get an added benefit. We can test terminal units for clients or if we need to troubleshoot an air distribution device that we can't get good, accurate field measurements on, or multiple types of field measurements on. We can bring them in and set up our lab. We use our lab for verifying our flow hoods for calibration verification, things like that. So we get other benefits out of it, but it's really there for doing testing for the control systems, terminal units. We can do air distribution devices, things like that.
Sure, and like I mentioned earlier, we had a project where y'all were doing either the test and balance or the commissioning, I'm not sure, but we had some discrepancies between
the temperature sensors.
Our temperature sensor that was in the system and y'all's readings, and so brought the sensor here, put it through its paces, and found that the sensors were working properly, but it was the math and the PLC where we were getting the issue. So we were able to go make the changes there and ultimately systems working.
What's interesting you bring that up, because that's something we haven't even talked about. We do all of our own calibration verification in-house, and we've developed those procedures over many years. Some of it's been trials and tribulations and learning how to do it correctly. But we've got a really good process now, and we don't adjust our instruments. If they're found to be out of calibration, we'll still send them to the manufacturer. But you can imagine, we're right around 170 people right now, so we've got a lot of instruments out in the field for testing and balancing and building commissioning. And so it would be time and cost prohibitive to have to send those off. So we've invested in, especially the temperature measurement. We have a very, very nice temperature calibration setup, very nice pressure measurement, to get real precise pressures for our manometers. Got a great hood set up for testing our flow hoods and things like that. And so that's something, again, we don't really highlight it, but we're real proud of it. And we even have other folks that send their stuff here and ask us to check it. We like I said, we don't offer true calibration services, but we do have people that say, "Okay, can you check my flow hood? Can you check?
Is it in the right ballpark?
Yeah. Can you check my manometer?" We, it's interesting. We have some sheet metal companies that send us their duct pressure test rigs to check their orifice measurements, and we've done some of that. So it really the lab is the springboard for that. It gives us the capability because we have to have high precision in that area. So
absolutely,
it helps us to do some of those things that aren't everyday services.
Absolutely. So when you kind of brought up a lot of the complexity in the systems today, and I think especially on the air side, everything that's happened over the last year with COVID has definitely added to that complexity and the control sequences, things like that.
Sure.
When you're thinking about those building owners or the building engineers, what kind of advice would you have for them, either in operating their current building or if they're going into a new project, maybe some things to look for in design or the commissioning process?
Well, that's that's a tough one. I was, I guess, blessed and a little surprised to be asked to be on ASHRAE's pandemic response task force. I was I was part of the building readiness group there. I didn't chair it. I was just a member. Had some great leadership there from Wade Conlon, but it was interesting because we were tasked with looking at that.
Sure.
What do you do when you shut down a building because of a pandemic, and then more importantly, how do you bring it back online and make it safe?
Can't really just turn it off, right?
Correct, and that was the whole purview of our group. There were others that were looking at a lot of other things, but that was our group looking at that. And the biggest thing that we came up with is, ASHRAE's, I have to plug ASHRAE's guidance here because that's kind of what everybody's saying in the industry we should be following. And that is, if you can increase your filter efficiency, do it, when you need to. Obviously, you're going to have potential performance impacts there.
Sure. Potential
energy impacts. And that's where you have to weigh that and weigh the benefits versus the costs there. And then I'm not too sure. I'm not of an opinion yet of what's going to happen with the codes in the future. I think there are going to be changes to the codes,
sure,
especially in the healthcare realm, with respect to what we learned in this pandemic.
Yep.
Good, bad, or ugly. But as far as just regular commercial buildings, I don't know what's going to happen. I think my gut feeling is we're probably going to kind of just digress back to where we were.
Sure.
And then we'll learn on the next one because we tend
we
to repeat our mistakes, right? Yeah. I hope that's not the case. The other part was increased ventilation. That poses a lot of problems It has to be done very, very carefully. And so that was really the focus of the recommendations that were made as part of that task force was, here's some strategies, but what's most important is that you engage a team that understands your system, team of design professionals, tab professionals, maybe commissioning providers if needed, depending on the complexity of the controls, good controls vendor, because you don't just go crank open your outside air dampers. That can cause a whole lot of other bad problems, right? Especially here in humidity-laden environments like we have here in Houston. And so it's not a one-size-fits-all approach, as many things in our industry are not, right? It's more of you got to have an engineered solution.
Sure.
And so moving forward, I think what we're going to see and what we're already seeing with some of our clients is they're going to try to put better filters in. We're seeing our K through 12 clients, a lot of them, trying to do better on the filtration side. We really haven't seen too much here in our market of increasing ventilation rates because we just have humidity challenges. I mean, the equipment in many instances is already running right on the ragged edge of what it can do in our peak cooling season. And so I don't anticipate we're going to see a lot more there, but they are doing filtration. They are doing what's called flush out, where they may start the system earlier and do more ventilation early on, and then when you get into the early morning or in the evening to flush the building, but not run that increased ventilation rate during peak cooling load, right? You still got to be careful with that, but there are ways to do it appropriately. And so a mix of all those strategies, I think, is going to be employed by the folks that want to make their facilities better. From a design standpoint, I really can't speak for where it's going to go. I have a hard time believing you've got that big fight between, like we said earlier, the energy codes and safety and comfort. And the energy codes, are getting more and more tight, trying to push everybody toward reduced energy use. And in some instances, that's easier to do or easier to say than it is to do. And so we'll just see what happens because it's going to be a constant struggle there. Mm-hmm. And then, it really comes down, hopefully the design professionals finally raise their hands and say, hey, we're sacrificing safety here at this point. We can't cut this anymore. And it's going to take that dialogue. And I'm thinking we're going to see that coming up in ASHRAE and really hopefully get some folks at the table going, what's the right mix? And then back to what I said about healthcare, what I think we're going to see from what I've seen from many of our healthcare clients, I think ASHRAE is going to go toward mandating, and the codes are going to eventually mandate it, that they have to have more areas that can be converted at a moment's notice. You would have control sequences where you can change the ventilation rates, change the airflow directions in patient rooms, go into a pandemic mode. And we did a lot of that manually this past year for many of our clients, but obviously we had to go in and do it from a balancing perspective. We had to go in and change set points in the control systems. We had to go in and verify it. We had to go in and verify pressures. And then we had to put it back because the systems were not designed for that originally. And the current codes don't really design for that, right? So we're still in the process of putting some of those facilities back, thankfully. We're putting them back, right? We don't need those rooms anymore. But that's what I anticipate seeing. I think we're going to see more than the one or two AII rooms per floor. You're going to see where you can isolate an entire wing. They can just flip a switch. The whole thing will go into a pandemic mode, and they have an entire ward or section that they can use for that purpose.
That's really interesting, and I know a lot of the focus has been on the air side, and obviously airborne disease with COVID, but a lot of the conversation that we've seen on the water side has been around the domestic hot water, and that balance between safety and energy is definitely happening on the domestic hot water side. And so, I mean, you have conflicting advice within ASHRAE between 90.1 and the standard 188 guideline 12 for Legionella. So I agree. I think we're going to see that same conversation happening on the water side, and obviously a whole nother discussion on the balancing of domestic hot water systems. We wanted to get into that, but definitely kind of an area of interest over the last year that's really kind of cropped up, and and part of that started with the low occupancy, the low use, and the kind of Legionella leading the way of that bacteria growing in the buildings, but just in general, we're seeing bacteria growth and potential in the hot water loop. So definitely been a place that we've been kind of focusing, but it's along that same line of the balance between safety and energy. So I
think there's going to be a lot that we see changing with it's going to be good lessons that were learned
Mm-hmm.
out of this. And it's an unfortunate situation, tragic situation in many instances. But I think it's going to bring about some good change. It's just going to have to be done in a smart fashion.
Sure.
And not shoot from the hip and let's just go radical on the codes.
Yeah, we
right?
don't want to overshoot. So, if so, what would you say, or what kind of advice would you have for the building owner who's looking for, or what should they be looking for in a TAB professional or a commissioning agent?
Great question. So we get this a lot, and the big question that we get is what's the difference between the different certifying bodies? Okay. We're a member and obviously a charter member of the Associated Air Balance Council, or AABC. There are two other major organizations out there. One is NEBB, or NEB, and the other is TABB. And there's some other smaller ones. So somebody out there, hopefully they don't chastise me too much for not including, but those are the three main organizations, right, that certify the professionals in the industry of the TAB industry, that is, and even the commissioning industry. The real difference between AABC and NEB or TABB is the independence portion. To be a member of AABC and be certified under AABC, you have to be completely independent of the contracting team and the design team. So you cannot have a design professional that's doing testing and balancing under AABC. You can do that under the other organizations. You also can't have an installing contractor or a general contractor that's also doing balancing.
So
it has to
completely
be completely third party.
Gotcha.
And that's really the big difference between AABC. The other big difference is AABC is part of the total system balance, our national standard. It's an ANSI standard. It includes controls. It mandates controls verification.
Gotcha.
And that may be included in many scopes under building commissioning now, and that's you've got to coordinate that. But it mandates if someone else isn't doing it, that the TAB professional does at least a minimum control verification to try to ensure, like what we were talking about earlier, that the building's going to function as intended.
Right.
And so that's a big difference between the AABC standard and the NEB and TABB standards, or maybe some others that are out there, because they tend to put that over as an additional service, or include that as part of the building commissioning process. Not that they don't look at it; it's just not considered standard TAB services.
Okay.
And so the other part of it is performance testing. AABC mandates that we take temperatures and verify performance on heat transfer components, coils on air handling units, and things like that. The other organizations are going to test air and water flow, but they don't, as a standard practice, normally test coil performance. And so they won't take wet bulb and dry bulb temperatures and calculate BTUs across a cooling coil or a heating coil. And that's something under AABC standards we have to do that. So
Gotcha.
we're testing the performance of the equipment as part of the test and balance process. And we recognize that there's inaccuracies with field measuring compared to what you're going to get from a manufacturer's lab, but it's still, are we reasonably getting what the engineer needed from the design intent out of the equipment, given the situation? Because there's all kinds of things that can happen when a piece of equipment gets installed. And so that's the main differences. I mean, there's probably some other nuances, and I'm sure there's going to be some NEB folks and some TABB folks that tell me I'm wrong. But when you look at the specs and when you look at what we would typically provide as an AABC firm, standard practices versus other firms that are out there that are using NEB or TABB standards, that's the big difference.
Gotcha.
And when I go and talk to design engineers or owners, those are the major differences. And it doesn't make NEB or TABB bad. It's just that's the difference. And that's from an AABC standpoint, that's what we think makes us better. And I can say that, right, because I'm an AABC member. So
Yeah, but so like you said, I mean, y'all are completely independent. You do not have the installing contractor or the design side as part of your services, correct?
Correct. And that doesn't mean that we don't sometimes work under the contractor's umbrella. We here at EAB, we've been very blessed, and especially in this market, to do the vast majority of our work direct to owner, and we think that's the best way to do it. We advocate for owners to hire their test and balance and building commissioning professionals directly.
Sure.
But we realize there's instances where that's just not cost effective. It's not, the owner may not have the resources to do that. They may only want to write one contract. So we will work under the design team. We'll work under the GC. We'll even work under the mechanical contractor. I mean, and we do that on occasion, especially here in Houston. And in some of our other offices, we do it more frequently. But that's how most people associate test and balance services being procured, is under the GC or under the mechanical contractor. And we would argue that even if it's an independent firm should still be acting in the interest of the owner. There's still the opportunity there for things to not make it to the owner. And so that's why, and that rarely happens, but it has happened before, unfortunately. And so that's why we really push. We want to be direct to the owner. We want to be the owner's advocate.
Sure.
And at least have a clear dialogue with the owner where we can tell them what we need to from an independent standpoint. It's more mainstream on the commissioning side to be direct to the owner. That's
right.
Widely accepted in the industry. But there are times when the owner says, no, I want you guys under the GC's team, because at the end of the day, when they turn over the keys, I want to know it's all finished, and I want you guys to work it out. And with certain general contracting contractors, we have great relationships. We've done it many, many times on various projects, and it works out great.
Right.
But it's by and large, I wouldn't recommend that out the gate, especially not for an inexperienced owner.
Gotcha.
You're a lot better having your building commissioning consultant direct to you, to where they can feed that information direct to you as the owner.
Awesome. Yep. That's great advice. And again, I'm really impressed with y'all's facility here. Like you said, I don't know of any other place, definitely not in our area, but even potentially nationwide that has a setup like this. So I'm excited to get in here and go through y'all's fundamentals class. So,
great. Yeah.
Check that out. But any final thoughts or any other words of wisdom that you might have for our listeners?
No. I think we covered a lot. I think there's other things that we could go off on, and so
there's definitely some tangents. Yeah,
maybe we can do it again sometime. But
definitely.
No, we're just honored to have you here today. We're honored to be able to take part in this here in our facility, and appreciate you using the time on your podcast to highlight EAB and highlight what we can do here at our training center and through our other services. So, if you, I guess I'll give us a plug. If you're more interested in EAB, go to eabcoinc.com, eabcoinc.com, and check out our webpage and give us a call if you think we can help you on our projects.
Awesome. Yeah. Justin, like I said, really enjoyed it today. I learned a lot. I've learned a lot just kind of walking around and checking out y'all's facility. I'm more on the water side, so a lot of these the stuff on the air side has definitely been new for me, but always fun to learn, and again, impressed with you and your team and your facility. So
appreciate
thanks again for having us out.
Yeah, thanks, Tim. It's been great.
Well, also want to thank everyone for watching and listening today, and hope to see you on the next episode of Building Value.